All right. Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. This is a worksheet on Algebra 1 stuff, factoring by grouping. Most of the time, when you factor by grouping, notice all of these questions that we can see so far have four things, right? So 1, 2, 3, 4. Four things on each of them. And as we keep going here, that's what all of them have, right? So factoring by grouping doesn't necessarily have to only be four things, but usually when you guys are doing it for Algebra 1, it will be four things. It can actually be what's called a composite number of things. So 4 is like the smallest composite number, so that's why they give you 4. You wouldn't be able to do 5. You could do 6, because 6 is 2 times 3. Any number that is divisible by something. So it's kind of like composite is the opposite of prime. But anyways, so if you see 6 or 8 or 9 things, you could do factoring by grouping on those things, theoretically. But for our purposes, what we do is this. Right, so we're jumping into number 1 here. We want to take the first two things and group them. So what we want to do is we want to take out the greatest common factor of these two things, just the first two things, right? So step 1 is to divide out the GCF of the first two things, right? And they're usually called terms, but I think things is less formal, so I prefer things. Things and stuff and things. So you can call them terms if you want to be a little bit more fancy, but I usually don't try to be fancy, so I'm going to call them things. The first two things, we want the GCF of those two things. So what you're trying to figure out is what is the highest number that I can divide them by and not have a fraction. So I can divide by more than 8, but I'd have a fraction if I divided by anything more than 8. If I divide by exactly 8, I don't have a fraction, right? That's just for the number. That's just for the number. Now for the R's, you kind of almost have the opposite mentality, which is a little weird, but you want to take the smallest power of the letter they have in common. They both have R's in common. You take the smallest power of that because that's the biggest power you can take out of both. So even though it's kind of the opposite mentality, it still ends up being the same thing. You're taking out the largest thing you can from both without creating fractions. So if I divide 8r cubed by 8r squared, I just have r. And if I divide 64 by 8, I get 8. And then r2 over r2 is 0, or 1. All right, so that's the first part. Then you have the next part. So I'm going to use a different color here. The next part. So we group the other two. Well, there's really nothing in common. They don't have anything in common. So if that happens, then what you do is you take out a 1, so plus 1. And you keep the sign of the middle term here, the second from the right, I guess technically. There's not really a middle term. If this were a minus r, let's say minus r plus 8, then I would take out a negative 1. So I take the sign of that number out, right? But there's not really a GCF other than 1, which is kind of not a GCF, because it's like, if everyone had superpowers, would anyone have superpowers? Anyways, so plus 1, and then r minus 8. So here's the checkpoint. This is what's really cool about factoring by grouping is you can check your work without doing any more extra work. Because at this point, if you pause for a second, these two things, I'm going to switch to green here because blue and yellow make green. These two things have to be the same for you to move on. If they are not the same thing, then you messed up. If it's a worksheet on factoring by grouping, you messed up. If you're just trying to factor, it just means you can't factor by grouping. Or it could mean that you did mess up. also. But I did get the same thing. I got r minus 8. So if I divide by r minus 8, that would cancel out. And I'd have left 8r squared plus 1. And now I'm done. That's how you do it. So what we did was we divide out the GCF of the first two things. Then step 2, we divide out, same exact wording here, divide out the GCF of the last two things. Then, the last thing we did was step 3, we divide out what's in parentheses. Divide out what's in, I'm going to squeeze this in parentheses. So 3 steps. That's how you do this. It's a 3-step process. Divide out the GCF of the first two things. Divide out the GCF of the last two things. Divide out what's in parentheses. So it's basically like you're doing GCF 3 times. GCF, GCF, GCF of the GCFs. The GCF to end all GCFs. It's like Sauron's ring. So then we move on to 2. Let's do it again. Switch back to blue here. So GCF of the first two things. This time I'm going to write out what I'm dividing by. So 12. So what I do to figure out what the GCF is in my head is I start with the smallest number, because the GCF can never be higher than the smallest number, just like the powers, right? Can never be higher than the smallest power. So it's the same thing with the numbers. The GCF will never be higher than the smallest number. So start with 12. Well, is 21 a multiple of 12? No, right? Because 12, 24, that's already more than 21. So no. What about half of 12? 6. 6, 12, 18, 24. No, that doesn't work either. And you kind of just go through the list. So the biggest thing you can divide 12 by is 6. The next biggest thing would be 4. You can't divide 12 by 8 or 9 or anything like that. You can divide it by 6. You can't divide it by 5. You can divide by 4, right? That wouldn't work either. So that's one way to do it. That's kind of what I do, is I cycle through them in my head in reverse order. So the highest factors and go down to the smallest. The other thing you could do is you could factor tree it. If you're ever not sure, you could factor tree it, right? It's sometimes called prime factorization. Just write out all the factors. What I like to do sometimes, if you're really stuck, is just write out a list of factors. Write out a list of all the factors, like that. Now we have all of the factors. 1 and 21, 3 and 7, and I believe that's it. Then you circle what they have in common. They have 1 in common. They'll always have 1 in common. And they have 3 in common. And that's it. Which means that 3 is the highest power, or the largest number we can take out. Right? So we can factor out a 3. All right, so I'm going to erase this because I'm not going to have space here. So I'm going to erase because I will not have space. Okay. So we take out a 3. And then we can also take out 2 powers of p, 3p squared. So if I divide by 3p squared, I would have 4. Right? 12 over 3 is 4. P3 over P2, I'd have 1p left. 21 over 3 is 7. Carry the sign over. P2, P2, that cancels. All right, and then we do it again. So I'm going to skip to the part where I already know the GCF here, just to save time on this one. It looks like it's going to be 7. 28 over 7 is 4. 49 over 7 is 7. And look at that, it works. So then I factor out what's in parentheses, right? And what's left over is what goes in the other parentheses. And then I'm done, just like that. Okay. Now, as we go along here, I'm going to start to go a little bit faster as we pick up speed here. So if you just are stuck on some of the last questions, I won't be offended if you scrub ahead, grab that bar, and move it over to the right till you get to the problem you want solved or you're stuck on. What I would recommend that you do, though, is if you've already kind of figured out how to do this now that you've seen the steps and you haven't done this worksheet yet, I would recommend pausing the video before I get started on number 3. Try number 3 using the steps, and then if you get stuck or if you get an answer, then start replaying the video again until you either get to the place where you got stuck or you get to the answer and see if you got it. If you got it, awesome, you're already on your way. If not, then just watch how I did it and then try again on number 4. That's what I would recommend doing for this. That's what I'd recommend doing on every math video you watch, whether it's Algebra 1 or Calc 3, anything in between. This is a power of 3, by the way. I kind of got blocked by that little green parenthesis piece there. So here we go. GCF looks like it's going to be 2 and 2 powers of x. So if I take out 2x squared, I'm dividing by 2x squared. 12 over 2 is 6. x3 over x2 is x. This is just something divided by itself. So 6x plus 1. Okay. Remember what I said about if there's a minus sign here? If there's a minus sign here, even though there's 2 minus signs, so they actually have that in common, but even if there wasn't, I would take out a minus. If this third term is a minus, I would take out a minus. Looks like they both divide by 5. Okay, 30 over 5 is 6. X. 5 over 5 is 1. That's going to be positive 1, though, because I'm taking out a negative. Oh, forgot to put the number. Negative 5. Taking out a negative 5. So I'm dividing by negative 5. All right. And then 6x plus 1, 6x plus 1. I got the same thing in parentheses. So I'm on the last step now. Take that out, and I have left over 2x squared minus 5. And there we go. That's the answer. All right, let's do it again. So this time, what I'm going to do is I'm actually going to use a different color. We'll just use orange. And just do one color. So I did a lot of color coding, but it also takes time to switch between the colors. So like I was saying, we're going to go a little faster as we go here. So that doesn't go into 6. Let's go into 2. 2v2. So if I take out a 2v2, then I would have 3v minus 8. Okay, and then do it again here. Want to divide by, looks like 7. So I want to take out a 7. 21 over 7 is 3v. 56 over 7 is 8. 3v minus 8. And 2v squared plus 7. Okay. I don't know if I'm going to switch colors too much from here on out because it does take time to switch colors. Well, I'll switch from orange eventually because I will get tired of that color, but we'll keep it on orange right now. Let's see, number 5. 63 and 54. Man, what did they have in common? 9. They have 9 in common. Yeah. So 9 in squared. Take out a 9 in squared. 63 over 9 is 7. 54 over 9 is 6. Minus. These guys might go into 9 as well. Does that go into 9? No, that does not go into 9. It does go into 3, though. And they both go into 5. So if they both go into 3 and they both go into 5, then maybe 15 is the biggest thing I can take out. Yeah, maybe. So what I'm doing here is I'm trying to figure out if two numbers are pretty close together, then likely their difference is the GCF. That's a little trick you can use to figure out what the GCF. If two numbers are close, so 63 and 54 are pretty close together. When they're close together, a lot of times the GCF is their difference. Not always, but a lot of times it is, if the numbers are pretty close. So if you subtract them, which is what I did 63 minus 54 was 9. I was like, oh, maybe it's 9. So then I try to divide them both by 9, and I'm like, oh yeah, I can divide them both by 9. And also, if a number divides by 9, the digits add up to a number that divides by 9. 6 plus 3 is 9. 63 goes into 9. 5 plus 4 is 9. 54 goes into 9. Cool, huh? So, divides by 9. And then the other one was a little tricky. So 105 and 90. They both end in 5. Well, they both end in either 5 or 0. So they both divide by 5. So they both divide by 5 because they both end in either 5 or 0. Then also 105, 1 plus 0 plus 5 is 6, which means 105 divides by 3. 90 divides by 9, which means it also divides by 3. So that's why I was thinking, okay, well, if they both divide by 3, because of the 3 trick that I just told you about, and if they both divide by 5, because of the 5 trick that you probably already know, they end in 5 or 0. 15 is a pretty big number. Also, it's the difference between 105 and 90, because they're close. 105 and 90 are close. They're 15 apart. So you could use that minus trick again. If two numbers are close, then their difference is probably the GCF. Okay. So if they have a GCF at all, of course, you want to check it. But yeah. So anyways, that was my thought process there. 105 divided by 15. Now actually figuring out what it is when you divide it. Let's start with 90. That's a little easier. If you double 15, right, that's 30. 30, 30, 30 is 90. So that'd be 6. 15 times 6 is 90. Double it, times it by 3. That's the same thing as timesing by 6. So that's 6. If you do one more, it's 105. So that's 7. Okay. Well, then look at that. They are the same, which is supposed to happen because this is a factoring by grouping worksheet. So then we do that. We get 9n squared minus 15. And we're done. All right, that one had some crazy numbers on it. Let's see about number 6 here. 21 and 84. 84 might be a multiple of 21. Yeah, because if I times it by 4, yeah, if I times 21 by 4, I get 84. So 21 is the GCF along with 2 powers of k. So that would just be k. 21k cubed divided by 21k squared. 84 divided by 21 is 4, so minus 4. And that's it, because k squared over k squared is 1. 4 times 1 is 4. All right, then here looks like 15. Right, we were just talking about that a little bit earlier with the 15 multiples thing. 15, 30, 45, 60. So divide out 15, that would just be a k. 60 over 15 is 4. And look at that, k minus 4. We done did it again. There we go, 21k squared plus 15. Called that a day. All right, moving on. I do want to change color now. I'm starting to get tired of the color orange. We can go back to green. I really like green. What's the other tertiary or secondary color? There we go, purple. Purple's a secondary color. Let's do another secondary color. Right. 25 and 5 both divide by 5. And we have V2. 25 divided by 5 is 5. V. 5V2 divided by itself is 1. And then it looks like we would divide by 5 again, actually. Oh, no. Getting ahead of myself here. That would be a 6, not a 5. 6. 30 divided by 6 is 5. That's how I was getting ahead of myself. And then 6 over 6 is 1. There we go. Okay, and then 5v plus 1. Divide that out, 5v squared plus 6. Boom, shaka. We are done. Okay, let's do it again. 105, 175. I'm thinking 15 again, maybe. Yeah, thinking 15 here. Let's see, 15 divided by 1/7. Well, let's do the digits. Oh, actually, no, because 1 plus 7 is 8. 8 plus 5 is 13, which does not divide by 3. If it doesn't divide by 3, it's not going to divide by 15, so I was wrong. It does both divide by 5, at least, because they both end in 5. Yeah, because how many 15s was that? 105 goes into 15. Goes in, what was that, 7 times? Does 175 go into 7? This is a tough one. Does it? I don't think it goes into 7. 175 is just quarters. It's a bunch of quarters. 175, 75 ends in 75, so 175 ends in 75 is what I meant to say. Which means it's a multiple of 25. It's 25, 50, 75, $1. 25, 50, 75. So that's, oh, yeah, 7. No, yeah, it does go into 7. Okay. So then they both divide by 35. Wow, that was tough. When you're doing this, remember you can always fall back to, so I'm doing it in my head, but what you could do is you could just write out all the factors. If you're allowed to use a calculator, this is much easier, obviously. So I'm assuming that you can't use a calculator, because if I just assume you can, then it's easier, right? So if I teach you how to do it without a calculator, then you could do it whether you have a calculator or not. But if I teach you how to do it with a calculator, but you're not allowed to use it, right? So I'm assuming you can't use a calculator. But if you could, you would just what you would do. Here's what you would do, right? So if you're still listening here, here's what you do if you have a calculator. You take the calculator and you take the number, right? So 105, divide it by 2. Oh, you got a decimal? Well, that means it doesn't go in evenly. Try again. Try 3. All right. Oh, that went in evenly. Okay. Try 4. Nope. Try 5. Yes. Try 6. No. Try 7. Yes. Right. And you just keep going through the list until you get to you get all the things that it divides by, right? And then you write them all down. Write what it divides by and what's left over when you divide it. If it's a decimal, it doesn't go in evenly, and then that's how you find it, right? Just run through all of them using a calculator. If you can't use a calculator, you have to use divisibility tricks, like how do I know if it divides by 3 really quickly? Add up all the digits, right? So that's what I'm doing here, is running through in my head what it divides by. It divides by 7. That's a hard one. 7's a hard one to figure out. And it divides by 5 because they both end in 5. Okay, so that's going to go in 35, 70, 105, so that would be 3 times. So 3, oh, and n squared. N squared. So 3 n. How many times would it go into 175? Well, starting at 105, which we know is 3 times. If you add 35, it'd be 140. Add 35 again, you get 175. So it's 2 more times than that, which is 5 times. Okay. And then the n squareds cancel. So 3n plus 5. All right, and then over here, looks like these both divide by 25. 75 divided by 25 is 3. Oh, so also a minus. Minus 25. That's going to be 3n. 125 is 5 quarters. And there we go. 3n plus 5, 3n plus 5. All right, so 3n plus 5. 3n squared minus 25. Whew. Okay. Yeah, these numbers get a little crazy sometimes. Yeah, we'll stay with purple for right now. Purple's a good color. Okay. 96 and 84. They're kind of close. Their difference is 12, and yeah, I do think they both divide by 12. So we're going to go with that. 12n squared. 12n squared. How many times does that go in? Well, 5 times 12 is 60. One more is 72. So it'd be 12 times 6. Then one more would be 84. Right, so 7 times. And then one more after that would be 96. So 8 and 7. 12n squared and 8n minus 7 in the parentheses there. Then here, again, it looks like they're close. They are, looks like 14 apart. Yeah, 14 apart, so they probably divide by 14. Let's go ahead and try it. Okay, so 14. 112 divided by 14. Yikes. What would that be? We'd want to times it by something so that it would end in a 2. So, let's see. 5, 6, 4, 24, 7, 8. 8, maybe? 14 times 8? Yeah, because 8 times 4 would be 32. And then 8, and then add 3 to that. Yeah, so that works. So 8 in 98 over 14 is 7. So here's the other trick. So you have to be careful doing it this way. This is a faster way. Once I have this right here, this 8n minus 7 here, I know this is supposed to be 8n minus 7 if it's going to work. Right, be really careful with this because this is assuming that it's supposed to work. But if you do that, you don't have to figure out what goes in parentheses the second time if you know it's supposed to be the same as the first time, if you want to do it a little bit faster. Now you run the risk of maybe it's like you're saving a little bit more time, but you run the risk of getting the problem wrong even more because now you're not checking your work as you go. So it's possible, more possible, that you get the answer wrong. So this would just be if you're crunched for time, right? If your teacher just did not give you enough time for this quiz or test coming up where you have to do this stuff, if you're crunched for time, you can do it a little faster. I'll show you on number 10 exactly what I'm talking about. But for right now, we know we have 8n minus 7 on both, so we do 8n minus 7. And then we'd have 12n squared plus 14. And we're done. Okay, let's try this method that I was talking about on this next one here. So 28 and 16. 16 divides by, well, itself, but 16 doubled is 32, so it doesn't go into that. 8? No. 4? Yes. So it divides by 4. So 4, and then v2. 28 over 4 is 7. 16 over 4 is 4. Now watch this. Okay, so we know 7v plus 4, so we know the other one's supposed to be 7v. All I need to do now is just find out what the GCF is. It's going to be a minus. Looks like 3, because 21 is 3 times 7. 7 doesn't go into 12, so 3. Then I know what goes in the parentheses, 7v plus 4, because that has to be the same as the other thing. Boom, boom. 4v squared minus 3, right? So see how that's faster? Now, it means you're not checking your work, so you're more likely to get the answer wrong. If you have more time, if time's not an issue, I probably wouldn't do that method because you want to get the answers right, not necessarily finish the quiz as fast as you can, right? So, anyways, let's go back to green. I like green. Green's a good color. We're going to do that method a couple times here, and then I'll maybe come back to the old ways in a second here. And for the final ones, I might actually just use a calculator. I don't know. I've got a calculator sitting in my bag off screen here, but we'll see. So 4 v2 v minus 3. Okay. Minus 5. Right, take the sign. V minus 3. V minus 3. 4v squared minus 5. And there you go. Okay. What about this one? Looks like 7 x squared. 7x minus 5 plus 8. Excuse me. Need coffee. Yeah, I want to say 8. So then that would be a 7x minus 5 there as well. And yeah, that works because 8 times 7 is 56 and 8 times 5 is 40. So here's a way, this is a hybrid method. What I just did here was a hybrid. So I put 7x minus 5, knowing that it should be 7x minus 5, but then I multiplied it back out by 8 to make sure I got 56 and 40. Hybrid method. Forgot about that. That is maybe what I would recommend doing, no matter how much time you have on your test. It's a nice middle ground. All right, and then there's the answer. Okay. Let's see. 3. That's it. 3p2, 8p plus 5 minus 7. 8p plus 5. 7 times 8 is 56. 7 times 5, 35. Got it. Okay. 8p plus 5. 3p squared minus 7. Oh, by the way, I don't know if you noticed, but pretty much all of these problems. Let's go back. Let's go back a little bit here. So notice on number 1, even back on number 1, one of the things was like a regular variable and then a number, and then the other parentheses was a squared variable and then a number. I normally see like regular and regular. So like R and R, because it's like a trinomial and then you turn it into a quadrinomial, and then you do factoring by grouping. So that's what I normally see. But notice all of them are like that. So what we want to do is later on, I have a feeling like I actually haven't worked out this whole worksheet. I'm working this out for the first time with you guys. When we get to the later questions, I have a feeling like what's in here is going to be a difference of squares, and we could keep going. All right, we'll cross that bridge when we get there, but just heads up, you might have to keep going after you're done factoring by grouping. Okay, so definitely 4. 8? Yeah, 8 looks like that works. I think that's it. Let's go for it. 24 over 8, that'd be 3. 64 over 8 is 8. Minus, it's like 7. So we'd have 3r minus 8. 7, 8, 56. 7, 3, 21. Got it. 3r minus 8. 8r squared minus 7. Okay. Oh, now we've got like multiple letters here. So we just have to be careful. Not really anything crazy going on. We just want to factor out the GCF. So we're going to use the same method. I don't need to switch my method or anything. I just need to be a little bit more careful now that there's some extra letters happening. So 56 and 49. 7. Oh, and an x. 7x. 56 divided by 7 is 8. X's would cancel. So I just have w. 7, because 49 divided by 7. X's cancel. K squared. All right, minus looks like 3. Right? Remember, numbers are close. Difference is 3. That's what they divide by. Pretty much foolproof. All right, and then 8w plus 7k squared. Yeah, that works. All right, 8w plus 7k squared. In parentheses. 7x minus 3y. Right? Yeah, a little bit more complicated, but it still took me exactly 3 steps. So in a way, it is not more complicated because it took the same amount of steps. I don't have to change my method. I just have to be more careful with the extra letters. All right? 42, 36, they both divide by 6. And I can get an m to come out as well. So that's 7c plus 6d. Then over here I got minus. 7 and 6 don't have anything in common. N squared. Minus n squared. So I'd have 7c plus 6d. Yep. All right, 7c plus 6d. 6m minus n squared. Tally-ho! All right, let's see. I'm going to use tertiary colors now, like different shades of green and blue and stuff. All right, 3 x squared, 4, 12 over 3. X squareds are canceling here. 4u plus v. 7 y, 28 over 7, 4. Y's cancel. U plus v. All right, 4u plus v. 3x squared plus 7y. All right, on to the next one here. 5a. 40 over 5 is 8c squared plus 5. A's are canceling. K squared. All right. Oh, parenthesis was a little too close. I need to have something in between it. Too soon. Let's see. Plus 8? No. 4? Yeah, looks like 4. So 4b. B's cancel. 32 over 4 is 8c squared plus 5k squared. 8c squared plus 5k squared. And 5a plus 4b. And there we go. All right. So, nah, shade of green is too close to the other one. Let's do like a nice orange. Oh, maybe I was doing gold before. No, I was doing orange. Let's do gold now. Kind of like orange. All right. 4. B. B's cancel. 3c minus d minus 5 x, because x cancels. All right. Then we would take 15 divided by 5 is 3. C minus d, because we're dividing out a negative 5x. All right, so 3c minus d. 3c minus d, 4b, right, minus 5x. Okay. All right, here, let's start to see if we can go a little bit faster even than what we were doing. So 4n minus m plus 7, 4n minus m, 4n minus m, 4m plus 7. There we go. All right. Let's do it again. Keep the same color this time. 8, 7, 7. 7. 8y minus 5 plus 2. 8. Oh, 2r. 8y minus 5. There we go. All right, 8y minus 5. 7x plus 2r. Awesome sauce. Okay, do it again. 3x 7y plus 5. That's going to be a 5. R 7y plus 5. 7y plus 5. 3x plus 5r. All right, good to go. We are on the last few here. We have 6 more. Let's see, what color should I do? Let's do like a magenta here. Maybe we'll just stick with that for the last 6 here. What do you think? Let's do it. All right. A squared 5z minus 4c. I don't know why that was so tricky. Plus 3x. Okay. 5z minus 4c. Ooh. 5z minus 4c and a squared plus 3x. All right, next, 2 xy plus 3 minus 1. Wait a second. No, this isn't even factor. Yeah, this isn't factor, because I would only be able to take out a 1, and I'd have x plus 24y. And I don't have the same thing, but I didn't do anything wrong here. So, yeah, it just doesn't work. And even if I tried to restructure things, uh, maybe, maybe. Let's see. This one could be a really tricky one. So if I try to reorder things, this could actually work, and it might be a little tricky here. Let's see. So if I do the x first plus 4xy, then the 6, and then the 24y. Let's see. So negative x, 1 minus 4y, plus 6. Yeah, 1 minus 4y. Wow, that's tricky. Wow, okay. So I knew to structure it like that. I mean, intuitively, because I've been doing this for so long. But, yeah, 24, man, that was a tough one. I wonder if they're going to keep doing that now for the last few. So what I would say to do is, intuitively, obviously, is the best way, but you can't explain intuition. If you see a pattern, you want to follow that pattern. The pattern was these two both have x's, and these other two have y's. This term and this term have y's. This term and this term have x's. So I either need to put the x with the x or the y with the y. So I decided I was going to put the x with the x. So I put my x's together, and then my other stuff on the other side. Also, it's sort of like proportions when you set up a proportion. So I have my x's here, but then my y's are in the 2 and 4 spots, right? Like if you're reading it from left to right, 1, 2, 3, 4, first term, second, third, and fourth terms. So if I put my x's together, then I also want to group my y's. So if I put my x's together, 1 and 2 spots, my y's need to be in order as well. They need to be in either the even spots or the odd spots. 1 and 3 or 2 and 4. That's how you have to structure it. So that's like a step 0. Now we have kind of a 4-step process here. So step 0 is to get them all in the right order. You pair up the x's or the y's or whatever the letters are, right? And then you pair up the other letters differently. So 1 and 3 are 2 and 4, and then 1 and 2 and 3 and 4. Crazy. That's a hard question. We're actually not even done. So 1 minus 4y, negative x plus 6, and there we go. Okay, and then here, all right, let's see, are they in the same order? Let's find out. Well, we can do our method and figure out, right? So there's x, there's x. Here's a b, here's a b. No, it looks like they're not, because here I have a y and a y. All the letters need to be either 1 and 2, 1 and 3, not 1 and 4. Can't do 1 and 4. 1 and 4 doesn't work. 1 and 2, 1 and 3, 2 and 4, or 1 and 2. 2 and 4, 1 and 2. So you can't do 2 and 3. 2 and 3 wouldn't work. Or you could do 3 and 4. Right? 1 and 3, 3 and 4. Right? So that's how you have to structure it. Everything. Every letter has to follow that structure. So they're not in the correct order because my y's are in the wrong places. I have a 1 and a 4 there. It's almost like you're playing a game or something, you know, like you're trying to. Anyways, so we want to move the y. Let's just flip it with something else, right? So negative 12b squared plus 21xy plus 14xb minus 18by. But b squared doesn't go with anything, right? So it's also a little tricky because b squared doesn't go with anything. So because it doesn't, we would want to flip these guys around, actually. Let's see. So minus 18by, and then plus 14xb plus 21xy. So now, b squared b, and nothing. So it's decreasing, right? Another trick that I didn't do on 24. Another trick. B squared and then b, and then here it's b and then nothing. But they have the same pattern. I have b squared b, so it goes down one power of b. And then here I have a b, and it goes down one power of b. All right, that was tricky. Even more tricky than the previous one. And then I have the powers of y match up. So y here, that's fine. 2 and 4. The b thing was just weird because I had to get decreasing powers of b. I couldn't match a b squared with another b squared, unfortunately. So I had to have it decrease in the same way. That was even more tricky. But the x's are good. 3 and 4 is okay. That's a good pairing. And now I can do factoring by grouping. So I would do, let's see, I can take out 6 minus 6b. So I'd have 2b plus 3y. Then here I can take out a 7x and have 2b plus 3y. Good. Okay, and then, yeah, so 2b plus 3y. And then negative 6b plus 7x. Whew, okay. On to the next one. Let's see. So we just match them up. These don't have extra powers, so we can do it the same way we did number 24. So m. Okay, those are good. 1 and 3 is good. Z and Z. No, that's not going to work. 1 and 4 won't work. Let's look at the other things. So the m's are okay. The z's are not. So we need to move them so that they are in a better place. If I just move this one here, then the z's would be okay because I can do 1 and 2. Right, so 9mz. Let's do that real quick and let's see if that fixes everything. Minus 12nz plus 3mc. That's not changing. Minus 4nc. Okay, now let's check again. M. Okay, we're good. 1 and 3, that's good. Z and Z. 1 and 2, that's good. N and N. 2 and 4, good. C. 3 and 4, we're good. Right? If you just have individual powers, or if all the powers have a match, an exact match, then that's exactly how you do it. 1 and 2 is good. 1 and 3 is good. 2 and 1 is good. 2 and 4 is good. 3 and 1 is good. 3 and 4 is good. 4 and 2 is good. 4 and 3 is good. Okay? A little repetitive because I kind of did all of them and then in vice versa order. But that's how it works. 25 was a little bit of a wrench thrown at an already complicated method because we had a power that didn't have a match, a b squared without a match. So I had to go in decreasing order. The power had to decrease for 1 and 2 and then decrease the same way in 3 and 4. That was extra tricky. Okay, we're ready to keep going here. We can go straight into the next steps. The step 1, 2, and 3, that is. So 3 z 3m minus 4 n. Okay. Plus c 3m minus 4n. All right, so then 3m minus 4n, 3z plus c. There we go. Okay. And the last two here. Let's see. We didn't end up running into that problem, I don't think, where we had the difference of squares. I didn't see one. I was expecting that, and we never did. Huh. Okay. Well, at least you were warned. They didn't have any of those, and we're already running on a lot of time here. So I'm not going to show you an extra stuff, but if you do run into a difference of squares, when you're done with your factoring by grouping, you do want to keep going. Normally, your teacher will count you off if you don't. Okay. So 28 and 25. I don't think they have anything in common. Wait, hold on. We're supposed to check, make sure everything's in the right order. 1 and 3, okay. 1 and 4, no. Let's switch 2 and 4. So let's see, 28xy plus 20y plus 35x plus 25. So we have x and x, 1 and 3, good. Y and y, 1 and 2, good. Okay. So then we factor out some stuff. 8, no. 4, yes. All right, so I subtracted them, right? 28 minus 20 is 8, but they're not that close. 4y, 7x plus 5. And then here looks like 5 comes out. And we'd have 7x plus 5. All right, there we go. 7x plus 5. And 4y plus 5. All right, on to the last one here. Here we go again with the decreasing powers, right? So if you have a large power, put that one first. 36u squared. Then we need a power of u. Well, we can do either one of them, I think. Let's do the uv. 30 uv. So you could do them in either order. I think you could. I think you could. But when we have a u2, we don't have anything to pair with it, and not another u power of 2 thing. We want to decrease by 1 power. So we have to have a u here to go with it because we're going down by 1 power. Right? So now the pairing is u2 down to u. So next we would want to do our u, 30u, and then go down to no power of u, which is the 25v. Right? No power of u. All right, so the u's are taken care of. Now we look at the v's. Are the v's good? 2 and 4? Yeah, they're fine. All right, cool. So now, let's see, 6u. So it'd have 6u plus, looks like 5v plus 5. We'd have 6u. It's gonna be a perfect square. 5. Okay, so 6v, and then plus 5. Yeah. Wait. No. Wait, what am I doing? 6. Yeah, 6u plus 5v. There we go. Yeah. Okay, cool. So it didn't end up being a perfect square. It's almost a perfect square, but not quite. So 6u plus 5 and 6u plus 5v. Not a perfect square. Close to a perfect square. Not a perfect square. Don't write it as a perfect square. Whew. Okay. So here's the answers. You can check me. All right. Let me know if I missed anything. Now, they also took out a GCF of the whole thing. I did not do that. If your teacher wants you to take out a GCF of the whole thing, then your other step 0 is to look for a GCF of all 4 terms first before you start on the main steps of 1, 2, and 3. GCF the first 2, GCF the last 2, GCF the GCF. So if your teacher wants you to do this, then you need to have a step 0 tacked on another step 0, so 2 step 0s. You need to find the GCF of the whole thing first. Then reorder everything if you need to, like we just did on the last problems that were hard. Then steps 1, 2, and 3. GCF the first 2, GCF the last 2, and then divide out what they have in common there. Okay. Yeah, and that's it. So I mean, if you found this helpful, if you've watched this all the way to the end, congratulations. This was a hard worksheet. I'm sorry your teacher gave this to you. If you like free stuff like this video, I try to make as much free stuff as I can in my free time, and I try to throw all of that stuff into my website, myersmathematics.com. Go check it out. You can grab my free guide, The 5 Math Mistakes Everyone Makes and How to Avoid Them, my main free thing. Just by going straight to the website. You don't have to go anywhere specifically. You just go to the main part of the website. It's right there at the front. You just click on it, and you just tell me where to send it to, and it delivers into your email box. So go do that if you want more free stuff, or you can watch some more videos like this. And that is it for me. Have a great one, guys, and I hope to see you in another video.